Well, believe it or not, we've made it to the end of another chapter in FST, and so this has kind of been the chapter that's been the marriage of a lot of stuff about functions and algebraic type concepts with about 3 different things mixed in that are to do with data. So this is the third of those things. We've learned how to translate a set of data back in Lesson 3.3. We learned about scaling a set of data in Lesson 3.6, and we're going to combine those 2 ideas together to work with one more kind of data notation. That's going to be the z-score, which is in Lesson 3.9. You're going to need 2 things for this. You're going to need this worksheet, and you also need a blank note card. So we'll make one more note card for this chapter. So we need a note card, and we need these video notes. Okay, so let's talk about what z-scores are. Sometimes when a person wants to know how his or her score or salary compares to a group as a whole, then one way to do this is to compute a percentile. So you could look at yourself as a percentile ranking, where maybe the boss is at the 100th percentile, and maybe part-time workers, the lowest paid person would be at the low percentiles, the 1st percentile or the 2nd percentile, something like that. Well, another way to analyze the same information is to utilize the number of standard deviations you are away from the mean. So what we would do is look at how many standard deviations a score or a salary is above or below the mean of all the other scores or salaries. Converting to z-scores enables scores or salaries to be compared to the other scores in the same data set. All right, so you could compare yourself to all the other kids in your class in FST if we collected statistics about, test scores in your class in FST, something like that. Okay, so we're going to make a note card, and on the note card it's going to have this information right here. So we're going to start by outlining this. You can call this Lesson 3.9, which is going to be on z-scores. Okay, Lesson 3.9, which is on z-scores. So suppose you have a data set, and the mean of the set of data is x with the bar on the top, and the standard deviation is s. Then the z-score for any member x of this data set is, and it's just this simple formula, x minus x bar over s, where x is called the raw score, so that would be your score on the test, or your salary, or your time in the 100-meter dash, or whatever the thing is you're trying to find the z-score on. Okay? X is the raw score, x bar is the mean, and s is the standard deviation. You might also note that the standard deviation is the s, so it'll be sx on your calculator. Okay, a positive z-score then would tell you how far the raw score is above the mean in terms of standard deviation, and a negative z-score tells you how far below the mean the score is in terms of standard deviation. So how many standard deviations above or below. A z-score is also called a standardized score. A standardized score. Now, can you ever think of an idea or a situation where you'd like to have a negative z-score? Would you ever like to be below the mean? And I want you to think about that, and we'll talk about that when we get back to class. But think of a situation, or more, there's more than one situation where it would be desirable to be below the mean. If you need to pause the video for a minute, you can, because you need to write this information that's in between these dashed lines on your note card. Okay, the next thing we're going to talk about then are the properties of z-scores. We want to know what happens to the mean and the standard deviation of a data set if each score is converted into a z-score. You might remember those daily earnings for the restaurant workers, those 11 restaurant workers that we looked at in Lesson 3.3 when we translated that set of data. Well, what I want you to do is to enter the data. Here were those amounts of salary that those people were making at the restaurant. I want you to enter those numbers into list 1 in your calculator, and then find the mean and the standard deviation. All right, so I'll let you pause the video and you can do that. Find the mean and the standard deviation. Okay, I put my data in and I see the mean is $70 and the standard deviation, the SX, is $5, isn't it? Okay, so in this table below right here, this is showing you that L1, these are the salaries. Okay, so these would be the raw scores or raw salaries. Okay, in list number 2 here, L2 of my table, I took the it's the image of those subtracting off 70. I'm going to subtract off the mean. So 60 minus 70 was a negative 10, 66 minus 70 was negative 4, and so on and so on and so on until this person who has 80 is 10 above the mean. Okay, then L3 is the image of L2 under a scale change of x divided by 5. Alright, so what you want to do is you want to divide everything by 5 because in the z-score formula we would do x minus 70, that's our x bar, divided by our standard deviation, which in this case is 5. So that's our SX, standard deviation. When we do that, we see we have everything from 2 standard deviations below the mean to 2 standard deviations above the mean. L3 represents the z-scores because each score minus the mean of 70, which is what happened in L2, is divided by the standard deviation of 5 and yielding the z-score. Alright? Now in our calculator we want to put the z-scores in list number 2. List number 2. So I'll show you a quick and easy way to do that. Come over to this list, jump up on top, and then let's just use our z-score formula. We would take every one of these raw scores, which are in list 1, and we would subtract the mean, which is 70, and then we want to divide by the standard deviation, which is 5. We will need to put parentheses around that numerator so it subtracts and gets the answer before it divides by 5. So here we could say second L1 minus 70 all divided by 5. Alright, so as soon as we hit enter, it should fill in those z-scores. So these are exactly the z-scores that we have in that little table right over there. Okay, now why do we put them in the calculator? Well, because we want to find the mean and the standard deviation of the z-scores. So now if we go to stat calculate, and we run the one variable stats on list 2, we see that the mean is now 0, and the standard deviation is exactly 1. Alright? So anytime we have a data set and the mean is x bar and the standard deviation is s, the mean of the z-scores will be 0. Did we get 0 for the mean of the z-scores? And the standard deviation of the z-scores will be 1. And that's the standardizing of them. We call it the standard score. That's when we standardize them and make them so that the mean is 0 and the standard deviation is 1. Okay, well let's do some examples. Okay, example 1 says Stacy scored 82 on a mathematics quiz for which the mean was 64 and the standard deviation was 12. We want to find her z-score and tell how far her score was from the mean. So remember the formula for z-score is going to be the raw score minus the mean divided by the standard deviation. Okay, so in her case, her raw score is an 82, the mean was 64, and the standard deviation was 12. So we would write our formula by saying z equals 82 minus 64 divided by 12. Okay, well, let's see what that would be. 82 minus 64 is 18. 18 over 12 to give us 1.5. Okay, so what does that mean? It means that Stacy's score, the score of 82, okay, was 1.5 standard deviation. And in our case, since this was a positive, we're going to say above the mean. Okay, above the mean. All right. Nolan scored 76 on an English test on which the mean was 70 and the standard deviation was 12. He scored 66 on a geography test on which the mean was 62 and the standard deviation was 4. Use z-scores to determine on which test he performed better compared to his classmates. So we need to get the z-score for English, and we need to get the z-score for geography. Okay. In English, Nolan scored 76, that's the raw score. The mean was 70, and the standard deviation was 12. So this would give us 6/12 or positive 0.5. So his z-score is positive, and that would beat all the negative ones for sure. Okay. For geography, we would have he scored 66. The mean was 62, and the standard deviation was 4. So 66 minus 62 is 4. 4 divided by 4 would be 1. So the z-score for that would be 1. Now, which did he perform better on compared to his classmates? Well, in English he had 1/2 of a standard deviation above the mean in that class, 1 standard deviation above the mean in geography. So the answer is going to be geography, isn't it? Because in terms of school, you'd want to be standard deviations above the mean, wouldn't you? Okay, let's try another one here. Frank tells a class that the mean on a test was 66. Frank has a raw score of 78 and a z-score of 1.5. What is the standard deviation? They're actually, in this formula, z equals x minus x bar over s. There are 4 variables. Anytime they can give us 3 out of 4, we can solve for the remaining one. So the raw score was 78 minus the mean, which is 66, divided by the standard deviation, which we don't know, and that's going to equal 1.5. So again, we want to set this up to look like a proportion, and we want to cross multiply. When we do, we'll get 78 minus 76, which is what? Let's see, 12, does that sound right? Okay, that's going to give us 12. So we're going to have 12 times 1 is 12 equals 1.5f. Divide both sides by 1.5, and 12 divided by 1.5 is going to give us 8. So the standard deviation must have been 8. All right? Okay, so that means I'm going to kind of leave this example number 4 for you to figure out, because you're going to use the table below with the scores from 2 tests to answer these questions. We're going to round all the answers to the nearest hundredth. We're going to answer some questions about Sheldon and Leonard and Howard and Raj, all characters from my favorite show, The Big Bang Theory. And so we just kind of made this problem up. This is what Sheldon and Leonard scored on the chemistry test with the mean and standard deviation given. This is what they scored on their government test with the mean and standard deviation given. And then you can work on questions A through D. And then we'll try to discuss those, make sure everybody's on the same page when you get back to class next time. So I think the all-time shortest video ever. Amen to that, right? And so if you have any questions or concerns with Z-scores, please let me know.